In 1998, two teams of astronomers, working separately, checking each other without knowing it, set out to measure how fast the universe was slowing down. Not whether it was slowing. That was not a question anyone was asking. The expansion born in the Big Bang had to be losing momentum. Gravity pulls matter inward. The math was settled. The only remaining variable was the rate of deceleration. They needed a number. What they found instead was a different universe. The universe was not slowing down, it was accelerating. And buried inside that finding, in data that both teams spent months trying to disprove before accepting it, was a consequence so strange that several physicists, upon first reading the results, went looking for the error. Not because the methodology was weak, because the implication was almost too large to accept. The consequence was this: there is a boundary surrounding you right now at this moment, beyond which no signal traveling at any speed will ever reach you again, not because of what lies beyond it, because space between here and there is stretching faster than light can cross it. Galaxies on the far side of that boundary are not dark, they are not destroyed. They are simply and permanently beyond recovery, and that boundary is shrinking, every second, quietly. You are watching the observable universe get smaller. You don't know yet what that means for you for this particular moment in history, for what can be known and what will one day become unknowable. That is where this is going. But first, look at something. You see that number, 2 trillion. That is the current count of galaxies within the observable universe. 2 trillion island systems, each containing hundreds of billions of stars, each separated from the others by distances that reduce them from where you stand to faint smudges on a photographic plate. 2 trillion galaxies, visible tonight in principle if you had the instruments. Most of them are already leaving. They have been leaving since long before you were born, long before this civilization existed, long before complex life first emerged in the oceans of a young planet. We are not watching a universe in motion. We are watching the conclusion of a departure that began billions of years ago and only recently learned we had been left. There is a word for the period you are living through right now. I will give it to you later because it will mean more once you understand how it was discovered and who paid the price to discover it. Her name was Vera Rubin. She was born in 1928 in Philadelphia. At 10 years old, she moved her bed to face the window so she could watch the stars move across the sky through the night. At 17, she applied to Swarthmore College and was told by an admissions officer that she might want to consider a career in painting rather than astronomy. She had a nice smile, he suggested, and art was more suitable. She went to Vassar instead. When she graduated and applied to Princeton's graduate astronomy program, she received no reply. Not a rejection, no reply at all. Princeton did not admit women to that program until 1975. She applied to Cornell. She was admitted. I think about Vera Rubin when I consider how knowledge is made not by institutions but despite them. The stars she had watched through her childhood window did not care about admissions policies. Neither did the data she would eventually gather from them. By the 1970s, Rubin was studying the rotation of spiral galaxies. Specifically how fast stars at the outer edges moved compared to stars near the center. The physics was not complicated. Stars farther from the galactic core should orbit more slowly, the same reason the outer planets in our solar system move more slowly than the inner ones. Distance from the gravitational center reduces orbital velocity. Every calculation said the curves should descend. The curves were flat. Stars at the outermost edges of spiral galaxies moved at nearly the same speed as stars near the center. Year after year, galaxy after galaxy, Rubin found the same thing. The outer stars were moving too fast, far too fast for the visible mass of the galaxy to hold them. By any calculation anyone had, they should have been flung into space long ago. Either the gravity we understood was wrong, or there was mass in these galaxies that no instrument had ever detected. Rubin presented her findings carefully, methodically, without drama. She was questioned. Her instruments were questioned. She gathered more data, more galaxies. The same result again and again. By 1980, the conclusion was inescapable. Most of the matter in the universe is invisible, not dim, not distant, invisible to every technology that existed then, or exists now. Known only by what it does, by the way it bends light around galaxy clusters, by the way it holds stars in orbits they have no right to maintain. The universe we can observe is the minority of the universe that exists. Vera Rubin died in December 2016. She never received the Nobel Prize. Physicists who had spent decades building on her work said publicly and without ambiguity that she had earned it. The Nobel Committee did not act before she was gone. What her discovery made possible, what her decades of unglamorous, meticulous work quietly enabled, is the part that connects to 1998, to the two teams, to the accelerating universe, to the boundary that is closing around you right now. That connection is not obvious yet. Hold it. Here is where your expectation will break a second time. You might assume that a universe expanding at an accelerating rate, galaxies rushing away, the observable horizon shrinking, is a problem for the distant future, a concern for civilizations that will exist billions of years from now, something that carries no weight for the present moment. It doesn't work that way. The acceleration has been underway for 5 billion years. The galaxies nearest to the edge of what we can observe are already so far away that the light arriving from them tonight left its source before the Earth existed. We are not watching those galaxies as they are. We are watching them as they were in a past so remote that the planet you are standing on had not yet formed when that light began its journey. The universe we observe is not the universe that exists. It is a historical record. A transmission from the past, arriving continuously, carrying information about conditions that no longer hold in the places it came from. And the record is getting shorter. Every year more galaxies cross the threshold into permanent silence. The information they carried, the spectral signatures confirming the universe's history, the redshift revealing how space has expanded over time, moves beyond the reach of any instrument that could ever be built. Not eventually. Now, tonight, while you read these words, I want to be precise about what this means, because it is easy to hear it abstractly and let it pass. The team that confirmed the acceleration was not one team, it was two, working in competition without knowing they were verifying each other. Saul Perlmutter led a group at Lawrence Berkeley National Laboratory. Brian Schmidt and Adam Rees led a separate group called the High Z Supernova Search Team. Each had spent years developing the same method, using a specific class of stellar explosion, a Type 1a supernova, as what astronomers call a standard candle. The explosion is consistent enough in its peak brightness that if you know how luminous it truly is, and you measure how luminous it appears, the difference tells you precisely how far away it was when it detonated. The method is elegant. The execution required years of work, thousands of photographic plates, and the patience to watch the sky night after night waiting for a star in a distant galaxy to die. Perlmutter's team had been gathering data since 1988, a decade of supernovae, each one measured across multiple nights, each one checked against what the expansion rate predicted it should look like. The distant supernovae were dimmer than they should have been, not dramatically, not by an amount that could be dismissed as instrument error, consistently, measurably, undeniably dimmer, meaning they were farther away than any model of a decelerating universe could explain. Perlmutter later described his team's reaction as disbelief, followed by months of searching for the error, followed by the slow and reluctant acknowledgement that there was none. Schmidt's team, checking independently, arrived at the same answer. Something between the galaxies was pushing. Not gravity. Gravity pulls. Something else. An energy filling the space between all things, pressing outward, winning against gravity, accelerating the expansion that began at the Big Bang. They called it dark energy. No one has measured it directly. No one fully understands its nature. What has been measured with precision that has only improved since 1998 is its effect. Now comes the connection that has been waiting. Rubin's dark matter, the invisible mass she spent decades proving existed, was part of what Perlmutter's team needed to account for in their calculations. To know whether the distant supernovae were too dim because the universe was accelerating, they had to know the total energy content of everything, visible matter, dark matter, and whatever energy filled the space between. Her work, which she completed before the method for measuring acceleration had been fully developed, was folded into the calculation that confirmed what she had not lived to see confirmed. Two discoveries made decades apart by people who never collaborated, built on each other in a way that neither could have anticipated. That is how knowledge works when it is not about the person making it. The period you are living through has a name. Cosmologists sometimes call it, informally, the observational window, the era in which the universe is young enough, and the evidence of its own history still close enough, for any mind that exists to read what happened. The cosmic microwave background, the faint thermal echo of the Big Bang itself, the oldest light in the universe, is detectable right now because the universe is still young enough for that radiation to fall within frequencies measurable by instruments we can build. As expansion continues, over billions of years, it will stretch beyond any receiver. The signal that confirmed the universe had a beginning will become indistinguishable from the noise of an emptying void. The large-scale structure of the cosmos, the filaments and voids and galaxy clusters that show how matter assembled after the Big Bang, is visible right now because the galaxies that trace that structure are still within range. As they accelerate beyond the horizon, the structure disappears from any possible observation.
A civilization arising 1 trillion years from now, technically sophisticated, patient, brilliant, would look out at a cosmos containing only the galaxies of its own local group. The surrounding dark would be absolute. They might develop physics of great elegance. They might ask whether the universe had a beginning, whether other galaxies exist beyond their own. They could not answer. The evidence would have been carried away, not hidden, gone. Carl Sagan spent the last years of his life returning to a single warning, that a civilization can develop the tools to destroy itself faster than it develops the wisdom to choose otherwise. He contributed to the scientific literature on nuclear winter. He watched his century build weapons capable of ending complex life on this planet, and he understood with precise clarity what it meant for a species to hold power it had not yet learned to carry. His warning was about the gap between capability and temperance, technology moving faster than the judgment required to hold it carefully. What the accelerating universe adds to that warning is a dimension he could not fully name. The knowledge we are building right now, the cosmology, the dark matter maps, the confirmation of dark energy, the measurement of the universe's large-scale architecture, is not infinitely recoverable. It exists because this window is open, because the evidence is still arriving, because the light from 2 trillion galaxies is still reaching instruments on this small world, and there are minds here willing to read what it carries. Some of what we know could theoretically be reconstructed from local evidence, given enough time and ingenuity. But as the horizon closes, the dataset narrows, the questions that can be asked grow fewer. The answers that can be verified diminish, not because the questions become less important, but because the universe will have removed the means of answering them. There will be a last generation able to observe the cosmic microwave background clearly enough to confirm the Big Bang. There will be a last astronomer to measure the acceleration that Perlmutter's team found in 1998, because eventually the distant supernovae whose comparison made that measurement possible will have moved beyond any conceivable observation. None of this happens soon. In any human timescale, it is effectively infinite, but it is not actually infinite. And the fact that you exist during the window, that life arose on this world during the era when the universe's autobiography is still intact, still legible, still confirming its own history through the light streaming in from every direction, is not something the cosmos arranged for your comfort. It is an accident, a coincidence of timing so improbable that most of the universe's history has already passed without any mind to observe it, and most of its future will pass the same way. You are not the purpose of the window, you are inside it. Return, now, to 1998. Saul Perlmutter's team is looking at data that doesn't fit the universe they expected to find. Two groups, neither aware the other has already arrived at the same answer, staring at supernovae that are too dim, distances that are too large, a universe that should be coasting and instead is running. They check the instruments, they recheck the calculations, they run the numbers again. The numbers do not move. Somewhere in those photons gathered from stellar explosions billions of light years away, light that had been crossing space since before the Earth existed, was a message. Not written for anyone, not transmitted with intent, simply present, available to the first civilization that had built the instruments to read it, and the patience to sit in the dark long enough to look. We were that civilization. We built the instruments, we gathered the light. And what it carried, when we finally read it, was the knowledge that the universe had been leaving long before we arrived, that the departure was already ancient when the first star ignited in the sky of a young Earth. The acceleration was not discovered in 1998, it was confirmed in 1998. It had been underway for 5 billion years before that night in the control room, before the data resolved on the screen, before anyone wrote down what the dimness of a distant dying star implied about the shape of everything. The universe did not wait for an observer to begin, but we became the first to measure what it had done, the first to name it, the first to understand that it had consequences stretching forward into a future no one can fully see. Vera Rubin watched stars through a childhood window and spent 50 years gathering what they revealed. Perlmutter's team watched stars die across billions of light years and found acceleration hidden in the dimness. Neither of them was looking for what they found. The cosmos rarely announces what it is about to teach. It simply moves. The galaxies drift. The boundary closes. The light that left its source before you were born continues its journey toward instruments that may or may not exist when it arrives. And somewhere at the edge of what any telescope can reach, another galaxy crosses the threshold, quietly, without ceremony, into the permanent silence beyond the horizon. The window is still open. For now it is open. What is done with that, with this brief and specific moment in which the universe is still readable, still close enough to interrogate, still generous enough to answer, that belongs entirely to the minds inside it. The cosmos offers no opinion on what they choose. It never has.